Hey everybody, welcome back to the Metal Mill 52 workshop. Today's episode is a compilation of segments that I've filmed over about 2 weeks while I finished up on the wheelhead bracket of the Quorn, working on the Quorn Tool and Cutter Grinder, and I wanted to show a little bit of the specifics. I'll go over an overview basically of the item, and then if you'll follow along with me, the remaining segments, about 20-25 minutes of machining videos, show the actual work. So to catch you up, in the previous episode we machined the wheelhead collar, that's the center part here, and the remaining videos that you'll see today are all about machining the wheelhead bracket. And this is a Mark 1 or Model 1 Quorn bracket. It's different from the Mark II versions in that the motor mount and the pulley cover and so forth are different. So there's a lot of stuff that goes into this, but I wanted to show the finished product. I'm really pleased with how things came out. Naturally, I haven't done any metal finishing yet, but you'll see all the steps with machining this thing flush, machining out the spindle bore. That took quite a bit of time, and most recently, just last night as a matter of fact, I made the adjustments for this, the adjustment knobs top and bottom for that adjust the wheelhead collar and allow it to tilt up and down. So that was a fun but time-consuming process, because you're taking a 1-inch piece of round steel and turning it down to 5/16 diameter for the bolt part, and then threading that by 32 threads per inch and knurling it and cutting it off just right. So there's 2 of those. I need to actually make 1 more of those and a washer that will be used for the work head. I'll go ahead and do that. It's just convenient to make that stuff while I have all the equipment set up on the lathe. I'll probably do that this afternoon. It's Saturday morning right now, so I thought this would be a good time to do a recap and an introduction video. So I'm taking out the second bolt here, and now also had to make these 2 pivot bolts that were made out of 5/16 inch cold rolled steel rod, and they have lock nuts on the outside of them, and I had to thread them and put a point on them, and they will then also put a screw cut in here, which I cover how to do that as well. And these pieces all need to be case hardened, so that's the reason these things and the other screw that's just like this that will go on the rocking lever, that will be case hardened as well, and these things are too. And there's another part of the thimble that I'll need to case harden also. So I'm going to remove the wheelhead collar from here. It's a little bit of a tight squeeze. I'll put that back where it belongs on the vertical column, and now you can see the inside and all the parts that were machined. Naturally, obviously, I have not finished this yet, but this project involves some really interesting setups, and like I said, about 2 weeks of hobby machining time. I didn't punch a clock when I'm out here having fun in the workshop, but I want to say it's about 12 or 14 hours. An experienced machinist might be able to do it a lot faster. I really took my time with boring out the spindle bore, and I found out that my boring equipment needs to be overhauled. I'm probably going to scrap some of it and buy new, but we'll cover that in a different episode. But the boring process to get the spindle exactly 1 3/8 inches, the spindle bore, that was quite a process as well. So anyway, please follow along, watch and enjoy the rest of the segments that show how that was machined, and I will catch you up. Probably, give me some feedback on this if you like this format. I'm thinking this would be useful. My whole idea is to produce videos that would help somebody that is wanting to build a machine like this and show them the ins and outs, so the aha factor of like, oh, that's how that goes together. Oh, I see the setups he used in machining that. That's the reason I wanted to do these videos. So I'm thinking if I do segments like this, even if it takes me 2 weeks to compile one, that might be the most helpful approach. So the next thing after this, and the parts that I mentioned before about the additional screw and lock nut, I'll be working on the actual work head itself, the part that sits right here that holds the work, and that's going to be a lengthy process. I figure I'm about 40% done with the project at this stage. remaining components that need to be made are the workhead, the tool holding, and then the spindle. Those would be the other 3/5, if you will. So it's going to be interesting. This is going to be a long process. Probably aside from the locomotive, this is one of the cooler things that I've made. So I'm just trying to enjoy it and pass along my experiences, and I hope that's beneficial to you. Thanks again for joining me. Enjoy the rest of the video. Alright, I've drilled 2 1/2-inch holes, as you can see here, where the bolts go through for the clamping. And I've put the device up on some blocks on either side, and just to get started and to get the initial clamping done. I did that on the other side too, under here. And as you can see, I've got a little dowel rod, an 1.1/8" dowel rod that I've fit into where this is actually where the grinding spindle will actually be eventually. And so I put the dowel rod in there just as a way to get the orientation straight. I just eyeballed it a few times with different squares that I have, and I actually even used this layout tool to, you know, I'm not measuring a precise measurement, but I can run it up and down and, you know, next to the dowel rod, and I can see if there's any space or not. And happily I've got it adjusted right now where it's quite perpendicular, you know, this direction, and I did it in the other direction as well. So let me twist it around and show you. So the idea here, and the reason I wanted to take a minute and explain, is I puzzled over this setup quite a bit and reread the book. And if you think about it, the Myford lathe, they're fortunate because they have T-slots in the saddle, or the cross slide on the lathe, so they can bolt something down to the lathe and bore horizontally. And I thought, you know, well, with this giant homemade angle plate, I've got the capability to set up the same thing with packing. I've got some steel and aluminum packing underneath here, and then I've got it bolted down steady, and then the rest of it is just a matter of alignment, just like I did when I was doing the bases. So alignment, and then clamping it very tightly. So this is what I've got so far, and I've got it good enough and square enough in the directions I need it to be, that now I can move the vise on the mill and take it over there, and then you know, get it all clamped down. Once I have it all clamped in place, because things might twist a little bit, then I'll double check my measurements. And again, you know, with cast iron, you're not looking for rocket science or you know, perfection, but for just a decent, you know, within a 50 thou or so, 1/16 of an inch, 62 thou of the orientation there, it'll be plenty accurate. I'd like to get it a lot less than that, you know, 20 thou or so. And I have been able to, I believe, with these castings and with things like this, been able to get the alignment within, you know, 20 to 30 thousandths. And if you do that with a casting and you've got everything securely clamped down, you should be in pretty good shape for the actual machining. So what I've got in mind, just to describe this, and I'll take video of it, excuse me, but put it in place, clamp it all down very, very tightly, make sure everything's square and aligned as it possibly can be, and also support it. I'll use some supports on the mill underneath and packing underneath there, just because the downward forces of drilling and end milling puts a little pressure on it. So the more support you have underneath there, the better off you are. So I'll put the supports on, get it all clamped as tight as I possibly can, and then the first thing I'll do is bore this. It's 1.1/8" now. It just needs to come out to 1 3/8". So bore that, and I'll be on center. I can use my DRO to mark center 0 0. I can come over here 2 7/8 inch and drill and tap the 5/16 18 hole, and then come up and do it on both sides, for that's where the pivot's going to be. And I'll do it straight down from this position, and then I'll be able to drill and mill out the slot here for the adjusting bolt. And the fourth thing that'll need to get done is to mill this part flat. And I can just, I think I'm going to use that giant shell end mill that I use on the I use so much in building the Gingrey shaper. So that's the little process so far, and I'll show you some machining steps, and we'll bring you back when the whole thing's done. Alright folks, I took the setup over off of the surface plate, tightened these bolts up here just so they were snug. I brought the surface plate over, and then I carefully aligned it along the x-axis there, and then carefully bolted it down and tightened up the wheel head bracket that needs to get machined. And I've got you can see the giant clamps on it. The nice thing is you can see now that it's higher than the top of the angle plate, and also you can hopefully see that it's pretty well aligned. I mean, it's not perfect to use a wooden dowel rod. I mean, that's not standard machining practice, but when you're working with castings, I think it's a decent way. And again, I got that idea from the book when they were talking about how to set this thing up on a Myford lathe. When it was with part clamped down to the lathe bed, they said first orient the spindle housing, the direction of the spindle, and that makes a lot of sense, because we'll have that, I'll machine that first, and then I'll be able to drill and tap my holes, and then drill and mill out my clearance places, and then mill this flat. And looking at it, I may have to remove this support, and I'm not sure if this will clear my shell end mill or not, so I may have to move the clamps around just a little bit. But it's going to be important to have this thing flat and in the same plane as the spindle, because what I plan to do when this is all finished, I'll be bolting this surface down to the table so that I can do the slit for where the spindle goes, the clamp. And speaking of clamps and stuff, you can see I have the support. I have a 1, 2, 3 block, and then a bunch of brass and copper packing underneath there, just to take some of the downforce, just to absorb that. I mean, I know I've got these giant clamps on here, but I think it's always a good idea to have the clamps there to support the downforce. So my plan is I'm going to let this sit overnight, and I'll think about, make sure I've got it set up just exactly like I want, and I'll do the machining tomorrow. It's Saturday night. I've got the thing set up and pretty happy with it. So I'll bring you back for the machining steps. One more thing before I do the milling. I eyeballed the X and Y 0, and that's how close I came, within 14th thou on the X and 4th thou on the Y. So I've got it. It's a rough casting, it's not a finished bore, but as you can see, it's indicating within plus or minus a couple thou inside there with the centering and coaxial indicator. So I think I'm all set to start the boring tomorrow. Finished pass on machining the base with the mill that I call the shell arbor mill. This thing's quite a project. Presents some very interesting challenges, as you can see. Kind of going over it. I'm in back gear at a fairly fast speed for the back gear. Camera's rocking because I'm cranking the mill handle with my left hand on the y-axis. I'll stop this in a second and do a little recap for the evening. Alright, coming up. Periscope. I've already machined this surface one time with this setting. Just kind of going over it again. Alright. Cut this off. Remove that. Just wanted to get a picture of that end mill, or that shell mill. I've used that for a lot of projects, a lot of times on the Gingery Shaper. Turn the phase converter off. So it's late on Sunday, not late, but it's quitting time for me anyway on Sunday evening here. And it's been quite a project. I've been out here for several hours. You know, I got it all set up and Saturday, and it was hours to bore, for the way I work anyway, bore the cylinder, the spindle hole, and that was the reason it took so long. Is I had to switch over. If you saw the segment, my 3/4 inch boring head is no good, it's worn out. So anyway, got that under control, moved over, drilled and tapped this hole, then I drilled pilot holes and then finish holes, the 11 let's see, was it 11/32, yeah, size, and then I milled this out clearance. This will be the side, if this is the bottom, then this will be the side that's most likely going to be used for the opening for tightening up the bolts. I think the prints call for both sides to be opened up, so I drilled the holes all the way through. Haven't milled out the other side yet, and I haven't tapped the other side yet. So doing this, I'm stopping work for tonight. I'm going to just leave everything sit, and then I'll come back at it hopefully tomorrow. And you know, I want to evaluate everything, and oh, I forgot to mention I did mill off this surface here and this surface here, so at least these are on the same plane. This one's actually a little bit lower than that. I didn't want to mill this all the way down to that level because there wouldn't be much of a rim there, but at least they're on the same plane. So if I end up deciding to put it in the vise or something, I could do that, and I could block this one up a little bit and get it level if I wanted to do that, to mill out the slot on the other side and to tap. So I may do that, but like I said, right now I'm going to leave it just like it is, go walk away from it. Learned that lesson a long time ago that, you know, when you've had enough fun, go ahead and stop and come back at it fresh. So I'll bring you back when I have the other side done and give a little recap. Just a note to add on, a little epilogue to Sunday night. Shows kind of the beauty of doing these videos, taking the segments. I realized after I turned the camera off, I said, you know, these two planes or surfaces are very close. The edge of the spindle hole and the edge of the bolt hole, if you will, the clamping bolt. So you might be able to surmise what I just did. I went ahead and machined or milled down. This surface is coplanar and flat and exactly equal with this surface. So now we have, this will be very helpful because tomorrow, if I want to, I can take everything apart. I can dial in the vise there, take all this stuff off, and then clamp this assembly in, you know, with these sides flat down, and then just use some packing on the edges to have this clamped down perfectly flat. And then the hole that's drilled through on the bottom for the 5/16 inch 18 tap, that will be all set, and it'll be, you know, so I can use the mill to tap it, and I can also machine out the remaining holes on the other side. And I think I should be pretty close to being done with this thing, so I'll probably hold off on publishing this video. I was thinking about doing it now, but I'll wait till I get all the way done. Spring pass on boring out the cylinder. I switched to a different boring head, and I realized my 3/4 inch is just flat worn out, so I'm back to a 1/2 inch one. I already took a full pass, about a 35 cut, and now I'm taking a spring pass. Just thought I'd shoot a little video of this just solid surface finish here, so that's a good thing. Alright guys, I just finished boring, got it right on the numbers. It's more of a happy accident than anything else, but right at 1.375 inch diameter. I wanted to show something. In order to do it with the 1/2 inch boring head, I had to grind down part of the stem of the boring head, of the boring bar. This was my longest one for the 1/2 inch, and I needed it to go down into the hole without interfering, so you may have to do that. Just thought I'd point that out. Another thing, since the next thing, after I take the boring head off, next thing I'm going to do is to drill and tap the 5/16 18 holes here. So one thing I noticed on the drawings that you get, if you print out off the internet, like off the Quorn group, these drawings, this is a magazine article, it shows 2 7/8 inch distance from the bore, but the book shows 3 1/8. And I checked the prints that I bought from Martin Model, and the prints also say it should be 3 1/8. So that's the dimension that I'm going to use, the offset from the center to the 5/16 18. Not sure if anybody else has noted that discrepancy. Most of the resources that I pointed out in the earlier project introduction, they built the version 2 Quorn, which has a different wheel head bracket. So the number 1 wheel head bracket, I'm going to do at 3 1/8 inch, and I hope that's right, by golly. Alright, here I've just finished drilling out and milling out the slot for one side of the bolting holes. This should be the duty side of it. So I think I'm going to cut the video off. I'll clean up that a little bit more, and the next thing I'm going to replace this with my carbide cutter so I can face off the 2 top ends, and then we have to address this part as well. Before I dismount, I thought I would run the cylinder hone, the brake cylinder hone, through the bore for the spindle. Well, I've got it all rigged up still, take advantage of the setup. Using this little brake cylinder hone, you can get these at auto parts stores. They're not expensive and they're a great piece of gear. I use this on my locomotive as well. The key is to keep the cylinder hone moving, and I did lubricate it with some WD-40. This gives you a nice finish, takes off any surface irregularities, which I may well have. You don't count on it to open up any significant distance, but just to give you a nice little smoother finish. So that's the piece of gear I'm using. Okay, I removed the casting from my giant homemade angle plate and reoriented my vise, got it dialed in, and now I've got the the wheel head bracket with upside down. Basically the machine side is down, and you can see how I'm holding it here. I've got packing in, I don't know if you can see it, but a little copper packing in there, and I zeroed out the hole here and just finished tapping the 5/16 18 hole here, and when I come back I'll be able to mill out this slot and mill this area down flat as well. Bring you back for that. Here I'm just getting started saw cutting for the spindle. I'm going very slow. I got it in back gear, as you can see, probably less than 50 RPM, just only feeding a couple thou per revolution, just doing it manually, just easing into it. I'm using some tap paste for some lubricant there. I've already drilled and tapped the holes, and I use the brake cylinder hone one more time to give a nice smooth finish to the cylinder and double check that it was in good shape. A little leery about saw cutting like this, but everybody else has built one of these things, seems to have done this for their spindle, Didn't seem to be much reason to try to use split cotters for this, so that's why I'm proceeding with this. As you can see, I've got it in the vise, the part that's milled flat, and I've also got a hold down to keep it secure from lifting and vibrating as I cut through. So I'm going to cut the video off and finish the process. Just another view of the slitting saw in action. It's been a half an hour since I started and I took that last segment, and I've been continuously sawing this thing. I think I'm a little over halfway done. I've just finished making the two cone-shaped threaded rods that go in. I used a piece of cold rolled steel, 5/16 inch cold rolled steel. I threaded it and I put a 60-degree cone on it and I cut them off. And the reason I wanted to show you this is I made these long on purpose, and I think that might be a good idea. I'll get this where you can see, because there are some clearance issues. I mean, if you can see, what I'm trying to show you is the outside of the vertical column collar. It's a tight squeeze in there, and I'm glad I made these a little long so I could adjust the movement side to side to give me good flexibility here. So now that I've put them on, I've got nuts on, I'll be able to mark them a little bit longer than that, and I'll cut them off to that length and then go ahead and make the screw cut. Now to get a video of this, here I'm cutting the screw slot in the end of the little screws that are for adjustment for the wheel head, using my little Dremel strap aluminum mount on the lathe. Got it centered. There we go. Get a nice screw cut when we turn the little whiny little Dremel off. Look at that. It's going to be good. Now to do the next one. As you can see, I rounded the end of the screw as well. Here I've just made the first of the two adjusting screws that will be used for the wheel head collar and the wheel head. It's 1 1/8 long, 5/16 32 thread. So I cut the threads with my lathe, and then I did chase them with the die, the tailstock die holder, just to get them smoothed off, and now I'm parting it off. Got to make this one and make one more.